In this lesson, we're going to look at adding real numbers, so adding integers, adding fractions, adding whole numbers, and so on. We're going to see positives and negatives, and that's what we're going to spend most of our time doing. So the sum of two positive numbers is positive, which makes sense. A positive plus a positive number is going to stay positive. The sum of two negative numbers stays negative. So if you think of it in terms of money, if your bank account is overdrawn, you're negative. You spend more money, that's another negative, you stay negative. If A plus B equals A, then B must be 0, because if you have a number and you add something to it, but it doesn't change, that only number it could be is 0. And two numbers whose sum is 0 are called additive inverses, which is just a fancy name for the word opposites. So an example of that could possibly be like 4 plus negative 4. That would be 0. If you have 4 and then you take 4 away, that equals 0. So let's look at some signed problems. What happens, though, we didn't really talk about what happens if the signs are different. What if you have one positive number and one negative number? Well, the sign of the answer just depends. It's going to depend on which number in the problem has a larger absolute value. So if the larger absolute value is a positive, then your answer will be positive. If you have a larger absolute value that was negative, then your answer will be negative. So let's look at a couple problems here. Let's look at the first one. We have 50 plus negative 25. So we have a positive 50, and then we're adding negative 25. You can think of that as money. You've got a positive 50, and then a negative would represent taking money away. And so what you're actually going to do when the signs are different is subtract. So since we're going to actually subtract when the signs are different, that means our answer is going to be a positive 25, because 50 minus 25. So you're actually going to subtract their absolute values, and whichever absolute value has a larger value, or is has a larger, or whichever one is larger is going to be the sign that you pick. So since 50 is larger than negative 25 and it's positive, our answer stays positive. Here both of our numbers are negative, so our answer is going to stay negative. So a negative 2 and a negative 17, when the signs are the same, we're going to add and keep the sign. So negative 19. 13, the signs are both negative, so you're going to add those together. So I'm just going to put 3.8 underneath. That's going to give me 11, a decimal point, and 5. So it looks like a negative 5.1. Now number 14, the signs are different. So I'm actually going to have to subtract 2/9 minus 7/9. And since 7/9, the absolute value of that term, is larger, then that means my answer is going to be negative, which makes sense because 2 minus 7 is going to be a negative 5/9. Recall that when you're adding and subtracting fractions, your numerator or your denominators have to be like, and as long as they're like, then you just add or subtract your numerators depending on what the problem asks you to do. Number 15. My signs are different, so I am going to subtract, but I need to get a common denominator first, which is going to be 6. So the first thing I'm going to have to do is multiply the second fraction by 2/2, because that's going to give me 2/6, and I'm going to add to that negative 7/6. Since my signs are different, I'm actually going to subtract and keep the sign of my larger absolute value. My larger absolute value would be the one with the 7, 6. 7, 6 is definitely larger than 2, 6. So I know that my answer will be negative. I subtract my 7 and my 2, and I get 5. Keep my denominator of 6, so negative 5, 6. And this one down here, number 19, looks a lot more complicated than it really is. I'm going to move it down just a little bit so we have a little bit more room. What I like to do in problems like these is I actually have two fractions that have like denominators, and I have two numbers. So I'm going to work with my numbers first. I have negative 32 and a positive 108. And then my fractions, I have negative 5/11 and I have a negative 6/11. And they actually have parentheses around them like this, with plus signs. So my number parts, negative 32 and 108, my signs are different, so I actually am going to have to subtract 108 minus 32. That's going to give me 6, and that's going to give me 7. So I'm going to have 76. And negative 5/11 plus negative 6/11, a negative plus a negative, so I'm going to add and keep the sign, will be negative 11/11, which is the same thing as negative 1. So I really have 76 plus negative 1, which is going to get me 75. Now let's look at this idea of additive inverse. You heard me say earlier it means the same thing as opposite. So what's the opposite or the additive inverse of negative 48? Well, that would be positive 48. And what's the additive inverse of 16.3? Well, that would be negative 16.3. Evaluate negative of the negative x when... Okay, so this can be kind of tricky. I'm actually going to do 26 first. So if x is 8.3, and I want to find the negative x, so I'm going to take this, and I'm going to substitute it in right there. So that's going to give me the opposite, which is another word for negative, or additive inverse, of the negative of the x, which is 8.3. So the opposite of negative 8.3, or a negative negative, is going to be a positive 8.3. What about negative 19? Well, I have the negative x, so I've got to take negative 19 and plug it in right there. So I'm going to have the negative, and then I'm going to have the negative, and then I got to plug in x, which is also a negative. So this one's a little bit trickier because x is negative, so that means I have the two negatives from the original problem, but then I got to throw in the third negative because x is negative. So if we start on the innermost parentheses and work our way out, the opposite of negative 19 is going to be positive, but then I got to throw in another one, so that's going to leave me with negative 19.